so in the last video we discussed the real number system as a combination of the irrational numbers and the rational numbers. And we also discussed the integers, the whole numbers, and so on and so forth. So you can always check back at that video and take time to understand the real number system. But I want to move on to discuss something very important, which is a sequel to that video, and that is the Surds or Surds. So I'll start my discussion. And what we have is Surds. So we have Surds. So in the Surds, we're going to first explain some things before I give you the definition, so we can get the definition very well. I made a definition of the rational number, and I said the rational number is numbers of the form m over n, such that m and n are actually integers. They are integers, and I said that n is not permitted to be zero. So I said these are rational numbers. These are rational numbers, as numbers that can be written in form of fractions. Can be written in form of fractions. Any other number that cannot be written like this are referred to as irrational. So if a number cannot be written like this, we will simply call that irrational numbers. So if we have, I'm not going to take much time to explain irrational numbers. I did that in the last video. You can check the last video. So if we have roots that gives us irrational numbers, such numbers are referred to as Surds. What do I mean? If I have something like this, of this form, so this is a Surd if, so this is a Surd if A is real, that's any real number, n can be any integer, and n root b is irrational. So this gives us an irrational number. So if this gives us an irrational number we have discussed, then all these forms what we call a Surd. Now you ask me, what is this? This is what we call a radical. So in mathematics we call that a radical. Don't allow that scare you, because I know you may feel someone and ask, what do we really mean by a radical? It's something you see every day. You see something like square root of 4. Square root is what we call a radical. So, but it's just that something like, for example, we see something like 4. So you'll be seeing, you actually see radical. So this is actually radical. But here, you ask me, I'm not saying anything here. Yes, it is commonly accepted that that should be 2. So if nothing is written here, that is referred to as 2. So this is simply referred to as 2. So on the other hand, if I have something like this, so this is called the cube root of 4. This is called the square root of 4, which is 2. We also have what we call the cube root of 4. And this can be represented as 4 raised to the power of 1 over 3. So now there's a relationship between powers and Surds. So there's a relationship between powers and Surds. What am I trying to say? If I have the square root of c, it's simply c raised to the power of half. If I have the 5th root of a, that is simply a raised to the power of 1 over 5. So that leads us to a very beautiful concept where we have, if I have something like a raised to the power of m over n equals to c. So I'm going to give my friend some good news that will change this to his mind. And the truth is that when we find anything like this, we can simply take out this and have it as the inverse here. So this will become n over n. So that may end up making you cry instead. but that will solve a lot of problems for you. If you have something like the cube root of 8 equals to a, if you have the cube root of 8 equals to a, this can also be written as a raised to the power of 3 equals to 8. Now, what do I mean by that? Because what I am saying here is that this is the same thing as 8 raised to the power of 1 over 3, a raised to the power of 1 over 3. And by my discussion here, I'm simply inverting this or reciprocating this to have this. So if this is 1 over 3, then if I'm taking this out to this side of the quality side, this is simply going to be 8 equals to a raised to the power of 3 over 1, which is actually this. And you know, that is actually obvious from our first video or second video. You see that this is a cube and 8 is actually 2 cubed, and having this power equal, hence we have a to be equals to 2. So that is some little mathematics that can actually wipe your tears and smile on your face. So this is simple, and this is what you think of whenever you're handling radicals. So I'll round up the video by putting on some rules that actually govern surds and radicals. Some rules, and I'll do that on this part of the board. We have so many of those rules, but the first is very important, and it's telling you that you can actually multiply 2 radicals and have a single radical. So this is very interesting. So you can actually multiply 2 radicals and you have a single radical, and you can actually multiply, or same thing with division. You can divide 2 radicals to have this. So this is permitted. This is actually permitted. You can multiply 2 radicals like a single radical. You can divide 2 different radicals to have that, but b is not permitted to be 0. But there are some warnings that we need to have. There are some warnings. We can also, if you have a single number multiplying with a radical, please, you have to leave them that way. Simply leave them that way. That is very important. And another thing, when we multiply 2 radicals that are the same, the good news is that we simply have that value in the radical. So this simply gives us a. So we have root a times root a, that is simply going to give us a. So we can have examples for that. So we can have example like the first one, simply say root 2 times root 3 is equals to root 6. That is only the same. The second one is simply saying if I have root 2 divided by root 3, simply going to give me just one root, and we have 2 over 3. The next one is telling me if I have 5 times root 2, you will be tempted to say root 10, that is wrong. But the rule simply say that is going to be written as 5 root 2. Just write them together. It's a number, it's a solve, you don't combine them. And the fourth one is simply saying we have root 3 times root 3, that will end up giving us just 3, not 3, just 3. So all these very interesting, what to think of when we are dealing with surds. So beautiful rule, and these are just the basic rules. We have many more rules, and for me to go into those rules, I need to introduce what we call rationalizing surds, rationalizing denominators, and how do we go with rationalization of the surds. But generally, the reason we study surds is simply that we want to carry irrational numbers along. Irrational numbers are scary looking and uninteresting in mathematics, but how do we carry them along? We only do that by writing them in surds form. Root 2 is 1.414231, and it's a very long, uninteresting number, but we can only carry it along by writing it like this on the surds. So that is why we study surds. So in the next video, I'm going to be talking about rationalizing of surds. Thank you.